Hi everyone, the question is how many different mutually non-congruent trapeziums can be constructed using four distinct side lengths from the set 1, 3, 4, 5, 6. We have to choose one of these four options which is correct. So here let's consider a trapezium whose sides are whose parallel side lengths are A and C, and let's say the legs of trapezium that you may want to say, or the two non-parallel sides, or possibly non-parallel sides, let them have lengths B and D. So here if you see carefully, if you shift this side which is having length D and put it here, this length is what D. So clearly you can see this length would be what? This length will be A minus C, or you may say mod of A minus C. Yeah. And what about this triangle? If I consider this triangle, one of whose side is B, another side is D, and yet another side is A minus C, essentially because I have clearly taken the longer parallel side to have length A. But in general, let's call it even a mod of A minus C. So you can say the third side is always greater than difference of the two sides of a triangle. So here mod of B minus D is supposed to be less than the length of the third side, which is mod of A minus C. So this is a constraint based on which we'll be deciding how many different non-congruent trapeziums can be constructed using four distinct side lengths from this set. So here ultimately it doesn't matter much whether I am taking A to be 4 and C to be 5, or C to be 4 A to be 5, because ultimately what we are looking for is mutually non-congruent trapeziums. So here let me consider a set A comma C, and let me consider a set B comma D. Now let's say A comma C is 1 comma 3. That means A can be 1, C can be 3, or A can be 3, B can be C can be 1, doesn't matter much. The point is the difference between A and C is 2. So difference between B and D should be less than 2. So that means B and D can be what all B comma D what all values this B and D can take. You can say 3 comma 4 has already been taken. So since we want distinct side lengths, it can be 4 comma 5, that means 4 and 5, 5 and 6, and that's it. So what if AC is 1 comma 4? That means difference between A and C is 3. So BD can be what? It can be 3 comma 5. It can't be 3 comma 6, because mod of B minus D is strictly less than mod of A minus C. So you can have 5 comma 6. Yeah. So now what if I have 1 comma 5 here, that means difference is 4. So you can have 3 comma 4. Difference of B and D should be less than difference of A and C. So 3 comma 4. You can even have 3 comma 6, because 6 minus 3 is 3 and 5 minus 1 is 4, and you can also have 4 comma 6. So what if it is 1 comma 6 A and C, then B and D can be what? B and D can be 3 comma 4, 3 comma 5, 4 comma 5. Yeah. Now what if A and C are 3 comma 4, difference is 1, that means B and D should have difference less than 1, which is not possible. Why? Because B and D are also supposed to be distinct. So here 3 comma 5, in which case difference between A and C is 2, so difference between B and D should be less than 2, that means it should be 1. So is it possible? 3 5 you take, so 1 4 or 4 6 or 1 6, no, you don't get anything. If you take let's say 3 comma 6, the difference between 3 and 6 is 3, so difference between B and D should be less than 3, so it can be 2 or 1. So here 4 comma 5 is the only possibility. Why? Because 1 comma 4 would have difference 3, which is same as difference of 3 and 6. Yeah, and similarly 1 comma 5 is having difference more than what the difference is there between 3 and 6. So next we take 4 6, difference is 2, so B and D should have difference less than 2, So 1 comma 3, 3 comma 5, 1 comma 5, no, you don't get anything. Yep. Oh, we have missed 4 comma 5. uh, so 4 comma 5 also you don't get much anything. Why? Because difference between 4 and 5 is 1, and difference between b and d should be less than 1. That means b should be equal to d, which is in contradiction with what the question says, that b and d also should be distinct. Yep. And similarly, 4 comma 5, 4 comma 6, and you have 5 comma 6 again. Similarly, you don't get anything. Yep. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 possibilities. That means 11 distinct, mutually non-congruent trapeziums, whose sides are distinct in values from the set 1, 3, 4, 5, 6. So B is the answer. Thanks for listening.